Okay, in this recording, I'm going to just talk about section 8.4 and what you'll be doing in this section. So section 8.4, you are going to be testing the population mean, which is mu. Remember, we always test a population parameter. Along with testing for mu, you will not know the population standard deviation. So sigma is not known. Remember, sigma again is the population standard deviation. So all you basically know about is your data set. You don't know anything about the population. And that's going to be important because the next section is going to talk about what if you're testing mu and you do know sigma. So when you're reading through the problem, you have to look to see if you know sigma or if you do not. And in this section, we will not know sigma. So therefore, since you're testing mu in step 1 of our testing, as you know, you have H naught and you have H sub 1, the alternative. Your null will be mu equals, and your alternative will be mu, and as you know, it'll be less than, greater than, or not equal. Depends on the problem. So again, the key is everything is set up the same as the previous section, except now we're testing mu. In step 1, I still would like you to put alpha. So whatever the alpha level is, I want you to put that. Okay, since we're testing mean, okay, up here, and we don't know sigma, step 2 then is going to be a t-test. Sometimes you'll hear it referred to as student's t, because actually a student came up with this, but we just usually refer to it as the t-test. But if you hear student's t, it's the same thing. Okay, so t equals x bar minus mu divided by s, that's s, my pen doesn't want to work right, divided by square root of n. Okay, let me write that a little nicer here. T equals x bar minus mu over s divided by square root of n. Now you want to keep track of this s over square root of n is a quantity in the denominator. So you want to make sure when you go through that on your calculator, you put that quotient as your whole denominator. Okay, the other thing I want you to remember with the t is we go to 3 decimal places. Now the reason we go 3 decimal places is because that's what our table goes to. So again, you're testing mu, sigma is not known, therefore you use a t-test, and here is the t statistic in step 2. Okay, so therefore in step 3, your decision zone, you have to draw a t-distribution. Okay, so there's a t-distribution. Probably looks familiar to you because it looks very similar to the z. Technically, a t is a little bit narrower than a z, and it's typically taller. So you'll sometimes see it drawn a little bit skinnier and a little bit taller. When I draw it, I just draw it similar to a z. It's uniformly shaped, it's symmetric on both ends, and it's normally distributed just like our z. So again, that'll be what our t looks like. So that's the overview of what we're going to be doing in step 4. Now what I would like you to do is make sure you have table A3 handy, because I'm going to start on the next page, but I'm going to be using and referring to table A3, so I want to make sure you have that handy either in your textbook or your cardstock tables that some of you have. So go ahead and get A3 out, stop this if you need to, and I'm going to move on, and I'm just going to practice with A3 before I get into any problems. Okay, so go ahead and get that table ready. Okay, so table A3. I'm just going to practice with it now. Table A3 you use to test the t's, or not to test the t's, but to look up the t values that you're using. There's one thing that's fairly new that you'll need in table A3, and that's something that we call degrees of freedom. We refer to as DF, degrees of freedom. And degrees of freedom for the t-test equals n minus 1. So as you know, n is the number of data values you have, minus 1, that's your degrees of freedom. So let's just say n is 47. Degrees of freedom for that problem would be 46. 47 minus 1. So now what I want you to do is look at table A3 and let's kind of get used to it. You'll see on the left-hand side, vertically, those are your degrees of freedom. Across the top, you'll see two rows. The first row is for a one-tail test. So one tail across the top. And the second row is for a two-tail test. And if you notice what you'll need for the first column, the one-tail or the two-tail test, you'll need your alpha level. So that area in the tail. So whatever alpha equals, that's what you'll need. So you'll need degrees of freedom. You'll need to know if you have a one-tail test or two-tail test, and you look in step 1 for that. And you'll need to know your alpha level, which you'll look in step 1 for that. So let's just practice a little bit. Okay, so let's say we have a problem. Let's just say this is an example. We have a problem, and let's say n equals 23. So if n equals 23, our degrees of freedom equals n minus 1. So 23 minus 1, which is 22. So first thing I need you to do, I need you to look down on that vertical left-hand column until you come to 22. Then let's just say we have a two-tail test. Let's say it's a two-tail test. And let's say that alpha is 0.02. Okay, so you look in the second column. So there's your first column. Look in the second column here. And look up alpha of 0.02. Okay, or second row, I should say. The second row, alpha of 0.02. But in that second row, I need you to follow that down vertically until you meet up with this 22, and you'll see a value there. So where your degrees of freedom, horizontal, and then go down vertically on that second row of alpha 0.02, where that meets, that's your value for t. So in this case, you should see that t equals 2.508. Okay, so make sure you can find that. If you can't, go back and practice this page here. I described the table and how you find things. So what I will need you to do before you move on to the problems is I need you to make sure you familiarize yourself with table A3 and finding these values. Okay, so I want you to kind of read through the section, familiarize yourself with all this, and then move on to the homework problems. Okay,